33 review for test 4. This is the third part. We are looking at complex fractions. Our first one is a simple one that we could just write across as a division. So we could look at it that way. And it's because there's only one simple fraction in each one. And then you would change to multiplication, inverting the divisor. First fraction stays the same. This one is going to flip. And nothing cancels for us on the diagonals, so we'll multiply across. X times x is x squared, and 5 times y is 5y. So that is our final answer. An alternate way to do this problem, let me just rewrite. Is to find the common denominator of both fractions, which would be 5x, and multiply on the numerator and on the denominator of this big fraction, right? And then when we simplify, on this one the 5 will divide out. It will leave us x squared. And this one, the x will divide out, which will leave us 5y. So we get to the same answer. This technique is a better technique for more complicated problems. For problem 14, we have another complex fraction. For this one, we're just going to use our second technique, which was to find the common denominator for both fractions in the complex fraction. This time it will be m plus 5. So we're going to do it, multiply by that common denominator on the numerator and then on the denominator of the large fraction. It's going to make these denominators cancel, and that will give us a simplified fraction of m squared over n plus 5. For problem 15, on this complex fraction, our common denominator is going to be a u and a 16. So 16u, we will multiply by it on the numerator, the whole thing. On the denominator, I would put it beside each piece. You can put it out in front and distribute, but I think it's easier to see if you go ahead and do it beside each piece. So we'll clean up on the numerator. These are going to cancel. So I'm going to have 16 times 8, 128. And on my denominator, my u's are going to cancel. So I have 16 times 4. And on this one, the 16s will cancel. So I have minus u squared. I could do a little factoring on the denominator, but it's not going to cancel. I have 128, and this would be 8 plus u and 8 minus u. So nothing cancels. You could have left it here. For problem 16, first we will pick the common denominator. And so we're going to need a's. You have to go with the most. So we're going to need an a squared and a 9. I'm going to put it beside each piece. I'm really doing numerator and denominator. So I'm going to do a 9a squared and 9a squared. That would be the same as distributing. And then I will clean up. In my first one, the a squareds are gone. So I have 9 times 3 is 27. In my second piece there, one of the a's is gone. So I have minus 27a. On the denominator, on the first one, my 9's are gone. I have 5a squared. And on the second one of my a's are gone. So I have plus 27a. So, on the numerator, if we tried to factor, we could take out a 27, and that would leave 1 minus a. On the denominator, we could take out an a, and that would leave 5a plus 27. Nothing cancels for us, so we could have left it at the original. For problem 17, for my common denominators, I'm going to need m's and a 2. I have to go with the most, so I need the m squared. So 2m squared will be the LCD. We'll use that with every piece. And we'll clean up. So on the first one of the m's will go, and that will give me 18m. On the second fraction there, the m squareds will go, and that will leave me minus 30. On this denominator, my 2 will go to give me 3m squared. And on this one, that m will go with one of these m's to leave a minus 6m. And we'll see if we can factor to reduce. On the numerator, we can take out a 6. That will leave 3m minus 5. Denominator, we can take out a 3m, and that will leave m minus 2. The 3 and 6 will reduce. 3 will go into 6 2 times. That is all that will reduce. So we could leave the answer here. I think the answer on the back of the sheet multiplies it back out to give 6m minus 10 over m squared minus 2m. But this would also be correct. Next, we'll look at a couple of domain problems. For domain, this is what the x can be. So we start with the set of all real numbers, and then we look for exclusions. We have two types of exclusions. One is denominators. Denominator cannot be 0, so we look to see when denominator will be 0. And the other type is a radical. The radicand needs to be greater than or equal to 0. So in problem 18, it's a denominator we have to deal with to see if we're going to throw anything away. So we want to know when this quadratic is equal to 0. Just factor and set each piece equal to 0. So we're going to do like signs both plus. And we're multiplying to give 6, but we're adding to get 5. So we're going to need to use 3 and 2 there. Now, don't forget what you're looking for. You want to know when this is equal to 0. So set each piece equal to 0 and solve. So when x is negative 3, it will give a 0 in the denominator. And when x is a negative 2, it will give a 0 in the denominator. So to state our domain, we'll do it in set builder notation. X such that, and it's implied, x is real, but x is not going to be allowed to be equal to negative 3 or negative 2. For problem 19, we are also just going to state the domain. So we just care about if the denominator is ever equal to 0. So go ahead and set it equal to 0 and solve. So k plus 9 would equal 0 if k is negative 9. Subtract 9 from both sides. So we want to throw negative 9 away. So for our domain, k such that k is not equal to -9.